Okay. Okay, so now I have lumping matching variant for the light condensate. Okay, and I will rename it as light. Okay, so yeah, I will conclude later. Now I go to heavy, the match one, the heavy one, and I will do the same operation. I want to do matching, lumping, sorry. Okay, so for this one, I will not do manual lumping, but I will use this operation, which is very good, auto lumping. And this one, auto lumping setting. You can lumping light components, number of light pseudo components that you want to include, and also lumping heavy components, number of heavy pseudo components. First heavy component, okay, first heavy component that will be the first component of the group, and the K values method. You can use Flash, negative Flash, or Wilson. I will use Wilson. And now I don't want to lump light, but I want to lump the heavy one. And I just want to create one heavy pseudo component. Again, it's a pseudo component because it's not component. It's pseudo because it's unreal. Okay, because it's a group of components. So we can call it pseudo component. I just want to create one pseudo component, which is a group of components. And I want to start the group from C12. So of course, it will be C12, C13, down to C20 plus. Okay, start from C12 with only one pseudo component. So if you click OK, open this one, of course, you will have auto lump from C12. Only one pseudo component, which I will call C12 plus again. Okay, so now I have this one. Okay, so with C12. And of course, I want to do matching. Control parameters all. I will maintain this one, or I want to improve 1%. And the same for this one, the default, run matching. Okay. Let's check the quality control. Okay, let's accept this one. I think it's quite okay. Okay, quite acceptable, the matching. I'm quite happy with it. Quality control and also the fingerprint, quite match. Okay, before and after. Yeah, fingerprint plot. So again, we can go to the component, and this one I want to call it lumping matching variant for the heavy liquid or heavy condensate. Click OK. I will close. Now I will call it light, and I will call it heavy. Okay. I tried to rename, but can I? L. Again, if I try to light, cannot. Yeah. Light lamp. Maybe I cannot exactly copy the name, the same name. I just call it heavy lamp or lamp. I think it's better. Okay. So let's make a story. This one is data. the variant one, light data, heavy data from laboratory. Then I want to create a model. The model should be matched with the data. Okay, but with the exact numbers of components, which are 24. And the match model is I call matching variant, light and heavy. But if I use the matching variant, the simulation will be too heavy because I have 24 components from each of the light and the heavy one. So I need to do lumping. Okay, I need to group several components to make a new pseudo component to reduce the number of components so that if I use that in my reservoir simulation, the simulation can be more relaxed. The calculation will not be too long. The simulation will not be too heavy, okay? Because now I reduce the number of the components. So I have variant, or you can also call it maybe laboratory, something like that, or maybe a variant. And you can call this one laboratory light, heavy light, matching heavy, lumping light, lumping oil, lumping heavy. You can name it as you wish. Okay, so far so good. Now after lumping, I can blend. Now I can blend the fluids that I want to blend to 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 create just one new fluid. Okay, so blending, you can blend two variants of two wells, for example, different composition, and you will get a new variant with new composition. Okay, so basically you can combine two fluids to create one new fluid. Okay, here you will add two samples, and again you need to match the samples and you can construct new variant. How can we do that? We can do that using this one, compositional blend.